circles, they just won't go away, will they, people? We're on number 5. We're looking at a circle. They're giving us circumference. They're wanting us to get to area. We have got to make up our table for calling Senor Rico. Call Dr. Rico right away, because we have a circle problem, and we've got to go all the way from circumference to area. The circumference is 600. We've got to jump from circumference to diameter, so there is a very special constant of proportionality we can use here. We divide by it because diameter is smaller, right? So we want to divide here. So 600 divided by this. It does say approximate, so I'm just going to use the number 3. That way I don't get all crazy here with my answer. So I'm just going to divide it by 3. Which, I could have done that in my head. That's 200, but oh well. Okay, so 200 is what we're guessing the diameter to be, which means that the radius would be, if the diameter all the way across is 200, then the radius would be half of that. We divide that by 2, so the 100. Now, to get from radius to radius squared, we take that radius, which is 100, and we square it. We find the area. 100 times 100. Gives me a pretty big number here, which is 4 zeros, so 10,000. And then to go from radius squared, it takes 3.14 of these squares to fill up the whole circle. That's our constant of proportionality to get from squared radius to area. So we just multiply by pi. But since we are trying to do an approximation here, I'm just going to do 10,000 times 3, and that's why I'm going to pick C, because that's 30,000. Now, you could find out exactly what it is. I think I did it earlier. It was like 28,000 and something, but it said approximation, so that's what I'm going to go with. All right, and number 6, we're going to wrap it up with this equation. So I've got an equation that relates D and T, so I am going to jump right in with a D versus T table. All right, D versus T. It says right here that I can multiply T times 3. So I can multiply whatever is in the T column by 3 to get what is in the D column. And this relationship represents D, which is in inches. So I'm going to put inches over here. And T represents how far the snail has gone in T minutes. So the snail is racing away from my wall. And this is the setup that we have. Okay, so what does the number 3 represent? Well, it gets us from side to side. That has a special name for us. That is our constant of proportionality. That is also the speed of the snail. So you could put that as the snail's speed, or how many inches per minute, if you want to put it that way, because it's going 3 inches per minute. Super fast snail, How many minutes does it take the snail to get 9 inches? We can start answering that by plugging it into our table over here. We put 9 under the inch column and think, what number could we multiply by 3 to get 9? Well, that's 3. So that first answer is 3 minutes. And then finally, how far will the snail be after 9 minutes? Well, we put 9 minutes over here. Our table simply tells us to multiply minutes times 3 to get inches, and 9 times 3 is 27. So there we go, 27 inches in 9 minutes. Man, that snail is booking it. And that wraps up Lesson 7's practice problems.